This is Ed Robinson of Kensington College, continuing our lessons on C#. Today we'll be talking about Linq. There's a Linq statement. Take a good look at it. It's not easy to write down sometimes, to remember. It's not easy to remember always. Just take a good look at it. We've got a from statement here, and then we've got a select statement at the end, and an in as well. It could be group at the end, but it always is either select or group at the end. I'm going to explain how we use this in a moment, but it's a good idea to try and just replicate that yourself for the moment. It's a little bit tricky to remember. We have the var in the front and then describing the type of the collection that we're going to have. From, remember, num in our whatever this is, selecting a particular num. So do try and remember the form of a Linq statement. Where does it come from? Well, I guess it comes from the old SQL, if you're familiar with that. It's the same sort of notation, select and from, but you'll notice that they're back to front, as a matter of fact. And I guess the idea that Linq, language integrated query, means the language being C# and the query meaning this SQL statement, so they've integrated that into C#. Now, these Linq statements are one-liners. There's only one line of code, and they do an awful lot in one line. In fact, they avoid looping, which is the main thing they do. They just pick stuff out of an array or some sort of collection in one line of code without the need to loop. So how can we apply Linq? Well, let's say we had an array of numbers, and we wish to find all the numbers which are, say, bigger than 3, which should result in that. Well, to get straight to the point, let's take a look at our Linq statement to do that. So that we've got our var, num query is the name of our collection of variables. The result, which is the 4565. From num in numbers, notice that that's the name of the array where num is greater than 3. So as I said, it's important to have the select statement at the end and the from and the in at the start. The stuff in between here is what we call clauses, and they can select, they can filter out the data basically. I'd like to take a look at the collection that's been produced so far. What I'll do is put a breakpoint here and then run my code and take a look at the num query here. If I just drop that down, I can see results view, and see that it's produced the 4565 for us at the moment. That's actually cheating a little bit. It hasn't actually been produced yet, but C# is being very kind to me and just giving me a preview, in fact, and I'll explain what I mean by that in a moment. But there you are. That gives you a nice idea of we have actually produced a collection of items, and we need to access those, as I'll show you in a moment. I think it's worthwhile considering what the alternative would be to using a Linq statement to do the same thing. It'd be something like this. You might create a new array. You're not quite sure how big this array is going to be, which is a bit of a problem. So every time you find an element bigger than 3, then you could put it into the new array. But you can see all this line of code is simply replaced by one Linq statement. So that's what Linq does. It avoids us looping through data to filter stuff out and search for things. So let's talk about accessing elements in our query collection. Let's say that we want to do access the first element, which indeed is a 4. So we could apply the element at, and then since we want the first element, then it's element 0 in our collection. Notice that we don't use this, unfortunately, don't use this simplified notation. We have to include the element at. So I'll just run it down to there, single step it from there, and if I take a look at the value of x, then I'll just press the F11. It's actually, and then it should, well, here's something interesting actually. It's gone up to evaluate the query. So this query is actually sort of sitting in memory, if you like. It's not actually activated until it's called. And so it's just been called to find the first element. So it actually executes the query now. It's called deferred execution. So now if I press F11 again, you'll see that it comes back with the result, which is 0. I could try and find the other elements as well in a similar way. If I could I'll just stop that and single step it, but it is interesting to watch it, because if I run it now down to this breakpoint, you'll see that it now, if I F11, as before, I'll press F11 and it executes the query and then comes back. I'm pressing F11 continuously, again, 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 again. You see how it's evaluated the query each time up till it finds the number. So again, now F11, again, 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 and then comes back. So the whole idea is that you can see how the execution of the query is deferred until it's required. I'll just keep yes, again, 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 and comes back and evaluates the results, and you can see that it does contain the results of well, it's giving the same x at the moment. We should have watched it as they're allocated. By the way, I forgot to mention that when using Linq, we should actually use Linq, system Linq, so don't forget to include that namespace when we're using Linq as well. Taking a look at this variable, which is the an implicitly typed variable, which means its type is actually deferred at compile time. So it takes a look over here and says what sort of things you're doing, and then it will know what type that is. Well, if you prefer, you could use this instead. The IEnumerable type, but I think you might prefer to just simplify it and use the var. Now we've seen how we can individually access elements. We can, because it is IEnumerable, we can use a for each as well. So now this will enumerate our num query collection, so there's no need to individually access them. So that if we were to build that and run it, then that should just iterate through our collection. There's our collection one at a time, and print out. Notice I've used the conversion to string as well because it is an integer. So we can run that, and that should produce our results. Now, so we have indeed used a loop at the end of the day, but let's see how this works when we do these individually. So I'll put a breakpoint in here, and then if I run this now up to the breakpoint, you'll see that every time we try to iterate, it should actually go up to our query. I'm continuing to press F11, and you'll see that it actually evaluates the query at runtime, i.e. deferred execution, and prints them out. Let's take a look at our query here. I like to think of it as a one-liner, but in order to make it a bit clearer, we can just break it up like this. But keeping in mind that it's still a one-liner, but it's easy, it might be easy for you to read and certainly to remember. So the compulsory bits are here and here. This is a clause. So we could, for example, vary that clause. We could have, for example, plus number is less than 6, for example, and that should now just produce that set. You can try that yourself. We can have more than one clause in here. We could have, for example, an order by, where we could print them out in ascending order. Well, they are at the moment. So if you left out the ascending, just deleted that, you would find that it did ascending by default. So we could try descending and try and run that to print those out. And you should find that your new collection of elements is arranged in descending order for numbers which are bigger than 3 and less than 6. We'll shortly talk about query methods, but for the moment, if we're talking about query expressions, I strongly recommend this particular website, the Microsoft Query Expression Basics. It's very good indeed. It follows up on what we've done so far. We'll return to our basic query where we found numbers bigger than 3 in no particular order, and we'll talk about query methods. We've been talking about query expressions. Now let's talk about a method. Let's say we wanted to find the maximum of all of those numbers. What I'll do is apply some parentheses here, or rather here, and see what methods we've got available. If I press the full stop operator, you can see the methods that are available. So for example, I'll find the max of those. Now, oh no, you'll notice that this down here, num query, is giving a bit of bother here. Well, why is that? Because num query, what we've actually produced, our num query, in fact, is an integer. How do I know that? Well, if you can see from here, actually, as a hold over the word max, you can see that it does return an integer. So this is not going to work, and in fact, all I need to do is to print out one value, which is an integer. Well, I need to print out my num query variable, which indeed is an integer. Perhaps I ought to name it something else, but to indicate that it's an integer, but it is just a single result. So if I were to run that, you'll see that it just produces the maximum value. Oops, I've to reinstate my braces and the max method, and if I were indeed to run that, it should find the maximum value of my queried array, not the original array, the array that we queried, which consisted of 4, 5, 6, 5, and so the maximum value being 6. You might try some others here. Take a look through and find the obviously the min you could find, or the count. Be interesting. Just try all of those, and in those cases they're producing integers. How about if we try to use the distinct? So if we type in here dot d, and it comes up with distinct. And if we were to run that, now we need to be a bit careful here, because what type is it producing? If we're going to write it out, is it going to produce a single value, an integer, for example? No, it's going to produce a new array, by the way. Well, when I should say collection, it's going to be distinct, so that means that we're only going to have one of these 5s distinct. But the problem is that it's producing now a collection, and I'm trying to write out a single element here, so that if I need to write them out using a for each, as I did previously. And if I were to build that and run it, that should just produce the distinct result as required. For the exercise, let's try and we'll produce another query which produces an integer once again, which is the sum of all of the values that we've selected, which should come to 20. Oh, but notice here again, it's complaining about the fact that we're trying to iterate through a collection, whereas we're producing an integer result. So we need to print out our value of let's see if we can run that and produce the total of all of those, which indeed is 20. What we could do, though, is, you might think this is a bit clumsy notation. What we could do is to produce another variable here. For example, we could say int s, and we could say that's equal to the value of our, well, we're just going to rearrange this basically, and then full stop, and we'll put the dot sum here, and then we won't need our parentheses here, and that should produce our result. So we're going to this time just print out the value of s, so if we were to run that, it should print out the sum, which indeed is 20. But let's note that in this case we still have this is our query result consisting of this collection, whereas emphasizing that now we have a single integer value which is equal to the sum of all the elements, one integer, whereas we're getting the integer result of the sum of this particular collection. So before we go on to discuss query methods and also lambda functions, it might be an idea at this stage to just revise and elaborate. As I mentioned before, this website will elaborate on what we've done so far.